Lockheed Martin's delivery of the 750th High Mobility Artillery Rocket System launcher marks a turning point in how the United States and its allies think about long-range precision warfare. For more than a decade, HIMARS has been the emblem of agile, high-impact firepower, but until recently it remained a relatively scarce, high-demand asset. Crossing the 750-unit threshold, combined with a rapid expansion of production at the company's Camden, Arkansas facility, signals that the system is transitioning from a niche capability into a fleet built for sustained operations and crisis response at scale. This shift has direct implications for deterrence, force posture, and the ability to react to simultaneous flashpoints in Europe and the Indo-Pacific. The headline figures are straightforward but strategically loaded. Lockheed Martin has doubled its annual HIMARS output from 48 to 96 launchers after a series of Army contracts, infrastructure investments, and supply chain upgrades completed ahead of schedule. That may sound like bureaucratic accounting, but in practical terms it means that every year, multiple new battalions worth of long-range launchers can be fielded, replenished, or transferred abroad without hollowing out existing inventories. In an era when battlefield lessons are being absorbed in real time, capacity has become as decisive as capability, and the ability to produce proven systems quickly is now a core element of national security. The decision to push HIMARS production into higher gear reflects two converging realities. First, the U.S. Army's modernization roadmap places long-range precision fires at the center of its approach to countering peer adversaries, especially where air superiority cannot be taken for granted. Second, partners who have watched the operational impact of precision rocket artillery in recent conflicts are no longer satisfied with static, towed or legacy tube systems alone. They want mobile launchers that can deploy rapidly, strike deep against infrastructure, command nodes, logistics hubs and air defenses, then relocate before being detected and targeted in return. Meeting both American and Allied demand requires an industrial base built for sustained output, not ad hoc surges. Camden has become a visible symbol of this recalibration. By expanding production lines, adding specialized workstations, and locking in multi-year orders, Lockheed Martin and its government customers are attempting to remove long-standing bottlenecks that traditionally slowed the delivery of complex weapon systems. Shorter lead times mean new units can be equipped earlier in their training cycles, allies can receive export variants in time to adapt doctrine and training, and planners can design force packages around reliable numbers instead of optimistic assumptions. For commanders tasked with deterrence on NATO's eastern flank, in the Arctic, or across the First Island chain, predictable availability of HIMARS is not a technical detail, it directly strengthens their ability to plan and signal credible combat power. The 750th launcher also arrives at a time when questions about stockpiles, industrial resilience, and wartime consumption dominate Western defense debates. Recent high-intensity conflicts have exposed how quickly modern armies can burn through munitions, launchers, and spare parts, and how slow legacy industrial models are to respond under pressure. By investing early to expand HIMARS capacity, the United States is attempting to reverse that vulnerability, at least for one of its key systems. A larger and more reliable production flow provides greater flexibility to support partners in crisis without forcing unacceptable trade-offs between external commitments and domestic readiness. For the growing list of countries integrating HIMARS into their forces, the significance goes well beyond the number of launchers they receive. Standardizing around a common platform creates shared training pipelines, compatible logistics chains, and aligned tactics, techniques, and procedures. Crews from different nations can learn on similar systems, employ comparable digital fire control, and plug into the same targeting architectures. A launcher produced in Arkansas can be deployed on European soil or in the Indo-Pacific and still fit seamlessly into multinational exercises, data networks, and resupply systems. This interoperability turns HIMARS from a standalone weapon into a collective tool for deterrence and coalition warfare. From the perspective of potential adversaries, the accelerating spread of HIMARS-like capabilities complicates strategic planning. Deployed across multiple Allied territories and armed with guided rockets and long-range missiles, these launchers can threaten critical infrastructure, staging areas, logistics corridors, air bases, and naval assets from distances that reduce exposure to retaliation. The prospect of dispersed, mobile launchers operating under shared intelligence, surveillance, and reconnaissance networks raises the cost of any attempt to mass forces near alliance borders. The fact that the industrial base is demonstrably scaling up underlines that this capability is not a temporary political gesture but a durable feature of Western posture. Achieving this expansion, however, depends on more than final assembly. It requires a stable ecosystem of suppliers providing propulsion components, electronics, launch modules, chassis integration, and test equipment. Predictable contracts and clear demand signals give those suppliers the confidence to invest in tooling, facilities, and workforce development instead of relying on unstable, one-off orders. That, in turn, reduces the risk of single points of failure and helps shield production from disruptions, whether caused by geopolitical tensions, resource constraints, or sudden surges in operational demand. The ability to maintain both volume and quality becomes a strategic asset in itself. The HIMARS milestone therefore serves as an indicator of how seriously the United States and its partners now treat the connection between industrial strength and credible deterrence. For years, Western governments have warned of a more contested security environment, but their defense industries often remained calibrated for peacetime efficiency rather than wartime endurance. Doubling production of a combat-proven system, reinforcing supply chains, and aligning procurement with operational concepts are concrete steps that begin to close that gap. If this model is sustained and replicated across other key capabilities, it will gradually rebuild the capacity needed to withstand prolonged crises or simultaneous theaters. Looking forward, the long-term influence of HIMARS will depend on how effectively it is integrated into a wider web of sensors, command systems, and advanced munitions. The launcher's true value lies in its ability to act as a flexible node in a networked battlespace, one day firing guided rockets against ammunition depots, another day launching extended-range missiles against air defense radars or maritime targets. As new generations of precision munitions are developed, a broad, fielded base of compatible launchers ensures those innovations can be deployed at scale instead of remaining boutique capabilities. In this context, the 750th launcher is not an endpoint or a publicity milestone, but a foundation for the next phase of Western long-range strike architecture. It represents the maturing of a system that has proven its relevance on modern battlefields and is now being resourced accordingly. For allies, it signals reliable access to a shared precision fires ecosystem. For competitors, it is a reminder that industrial capacity is once again being treated as a core pillar of military power. For soldiers and commanders, it means that the tools they rely on are no longer rare exceptions, but part of a growing arsenal designed to meet the harsher strategic realities of the coming decade.